Hi students, now we're going to start by the second video about conditional probability. So we call conditional probability, we have a condition of A knowing B event is realized before. The relation P of A knowing B is P of A intersecting B over P of B. So what does this mean? It means, let me give you an example to understand it. Suppose you have, for example, this table. You have girls, you have here boys, you have secondary 1, secondary 2. Suppose we have here 12 girls in secondary 1, 10 boys. Here we have 8 girls and here we have 15 boys. So directly you can put the total. Always I advise you when you have a table to put the total for all. So here the total is 22. Here the total is 23. Here the total is 45 of all. How many boys I have in the two classes? Girls I have boys 25 and girls is 20. Suppose the question is to pick a student. For example, find the probability of picking a girl. So probability of picking a girl. So you're going to tell me I want to pick one girl, so I have one choices out of 20 because I have 20 girls over a total which is 1 out of 45. So it will be 20 over 45. Suppose the question, what is the probability of picking a boy from secondary 2? So how many boys in secondary 2? So I have 15. So boy from 2, boy from secondary 2. So it's 1 over 15 over 1 over total 45. But if I put a condition, for example, I say from the set of girls, from girls, knowing from girls, what is the probability of picking a student from secondary 2? So when I say from the set of girls, so I know I'm going to go to girls. So now the universe is not this 45. It is not the total of everything. From the set of girls, so I know directly I want to go to the group of girls only. So I want not to take into consideration the boys. So here in that case, the universe will be the girls. So when I say P of A knowing B, so B is the universe. It's not anymore omega. From the set of girls, find the probability of picking from secondary 2. So from secondary 2, so I say in girls, how many from secondary 2 I have? I have 8. So I want to pick one out of 8 over total here is 1 out of 20. So what will be the answer? The answer will be 8 over 20. And if I want to do the property as it is here, so I want girls and from secondary 2. Girls from secondary 2, I have 8. So I want to pick 1 out of 8 over the total of everything, 1 out of 45, over P of B, and P of girls. How many girls I have? I have a 20. So 1 out of 20 over total is 1 over 45. So now in that case, these two cancel out. It's the same as doing it directly. So conditional probability, it means I have a condition. Here the part is the universe is omega, but if I use this part, for example, the total which is above and below will be cancelled. So that's why we can do it sometimes directly. Suppose another example. What is from secondary 2? Suppose I said from secondary 2, what is the probability of picking a boy? So from secondary 2, so the universe now is secondary 2. What is the probability? So I know from secondary 2, what is the probability of picking a boy? So I say P of boy knowing secondary 2. So here the answer will be So from secondary 2, so the universe is knowing from secondary 2, I want to pick a boy. So how many boy I have? I have 15, so I want to pick 1 out of 15 over total. It's not 45 anymore because I'm picking from secondary 2, from the class of secondary 2. So 1 out of 23, so it will be 15 over 23. If I want to apply the property, which is P of A intersecting B over P of B here, and I mean P of B intersecting S2 over P of S2, it will lead us to the same answer, P of S2. B intersecting S2, so it's 15. So it's 1 out of 15 over total 1 out of 45. And P of S2, if probability of picking from S2, how many S2 I have? I have 23, so 1 out of 23 over total also 1 out of 45. So 1 out of 45, 1 out of 45, these two cancel out. What remains? 1 out of 15 over 1 out of 23. So this is called the conditional probability. And I know X event appears before. So if the complement, because here the B, we know that P of A bar, when the universe is the omega everything, when we don't have condition, is 1 minus P of A. No need to put no, the universe is omega because it's very well known. But however, if I have condition, so P of A bar knowing B is 1 minus P of A knowing B. So I change only this set A, and certainly I don't change that of the subuniverse. If A and B are independent, we know that if A and B independent, P of A intersecting B is PA times PB over PB. So these two cancel out. So when two sets are independent, I have two conditions. If P of A intersecting B is PA times PB, if I have a conditional probability, if P of A knowing B is P of A. These are called independent events to prove it. So let us take an example to understand the conditional probability. A third secondary class is formed of three sections. 30% of students are in section A. So P of A, let me write the given first of all. P of A is 0.3. Whose 40% are girls? The girls are where? In section A. 40% of the girls are 40% in section A, 40% of students are girls. So I'm not in the total universe. In section A, so I know I'm in section A. So the number of girls there, the percentage of girls equals 0.4. When you have this kind of problems, directly put the complement of it. So P of G bar, not girls, boys, knowing in section A will be the complement. 1 minus 0.4 is 0.6. And 40% are in section B. So P of B of the students are in section B, such that 60% are girls. The girls here, P of girls, I know I'm in section B, is 60%. So directly the complement here of it, P of girls, not girls, boys, knowing section B will be 1 minus 0.6 is 0.4. And the rest are in section C. So C, if A 30% and B 40%, so C will be 30%. And the rest are where 20% are girls. So P here of girls, knowing in section C is 0.2. So the complement of it, P of boys, not girls, knowing section C is 0.8. Question A, find the probability of picking a girl knowing from section A. So it is 0.4 as we said. A girl knowing from section B is 0.6. A girl knowing from section C, is 0.2. You do the probability of picking a boy from section B. Boy and not girl knowing from section B, it is 0.4. Deduce the probability of picking a girl from section A. I didn't say knowing from section A. They want a girl and from section A. So I go to the given. I want girl with A. Girl with A, here you have it. We know the formula of the total probability. Probability, conditional probability of girl knowing A is probability of girl, this is the formula, intersecting A over P of A that we wrote up. Let us go to up. Here, probability of A knowing B is P of A intersecting B over P of B. So P of girls knowing. I want girls and from section A. So P of girl intersection A will be P of girl knowing A. P of girl knowing A, we have it 0.4 times P of A, which is 0.3. Similarly, P of girl knowing B is P of girl intersecting B over P of B. So what will be P of girl intersecting B? So P of girl intersecting B in that case will be P of girl knowing B, which is here 0.6 times P of boys, which is 0.4. And similarly for P of girl intersecting C, so P of girl intersecting C, it will be P of girl knowing C times P of C, which is 0.3 times 0.2. Suppose I said find the from the set from section A, knowing if I'm going to pick from section A, find the probability, or I want, for example, find the probability of picking a boy from section A. So I want a boy, not girl, and from section A. I didn't say knowing. A girl from section, a boy from section A. So I want not a girl and at the same time A. So I go here to the given. So I have it here. I want G bar and A, so this is G bar and A. So that's why I always put write the complement of the problem is better. So I say it's P of G bar knowing A times P of A. So what will be the answer? So it will be 0.6 times P of A is 0.3. Suppose I said I want the probability of picking a boy but not from B. A boy not from B and not B. So not B, I cannot do it this one, sorry. So that's it. This is a problem where we can use the conditional probability. So let us continue. Examples, given the following table of students in GSLS taking English and French. So this is the total here. Here total, I have GS students, 7 students are taking the English course, 13 are taking the French course. In LS, it's the same. How many English students I have? I have 12. How many French in both classes? 21. How many students in GS is it 20? How many students in LS? We have 13. The question here, we need to pick a student from the English section. So I want to pick a students from here, knowing from the English. When I say I want to pick a student from the English and one student from the French, I mean, this is, I have two subuniverse. One subuniverse alone is English, another is French. Knowing from English, I want to pick, knowing from French. So that's why I have conditional probability. Knowing English, knowing French. So I want to pick one from English and one from French. So I'm not going to take the whole table as one. I want to pick one from English and one from French. So this is called a condition. I'm putting a condition. So this is called a conditional probability. So I must have knowing. Find the probability of picking one from GS. I want one from the GS and one from LS. So here, guys, listen. So if I want to solve this problem, so what do I say? I'm going to say, Anna, I want to pick one from the English section, one from the French, such that one will be GS, one will be LS. Either I pick GS from the English, at that time I will pick French from LS because I want one from English, one knowing from English, knowing from French, but one from GS, one from LS. Or I pick one LS and the other from English and one French. So how do I write it? So I write it as follow. I want to pick two students, so I say probability of picking. Let me start by the blue one. GS, knowing from English first, I'm going to pick from English. So I'm going to pick GS because I want one from GS and one from LS. In that case, from the French, knowing French, I will pick LS. Plus, or I can pick from the English, not GS now, the green one, the LS, times probability from the French, I pick what? GS. So this is conditional probability because I want to pick one from French, one from English to be different, one GS, one LS. So probability from, I want to pick from the English section. Now the universe is not anymore 33, it's not. So the universe is the English sub-universe. So how many sub-universe I have? How many students I have? 12. So I want to pick GS. So how many GS I have in English? I have 7. So I say 1 out of 7 over 1 out of 12. Knowing from French, so the universe now is 21. So I wanted LS. How many LS here? I have 8. So 1 out of 8 over 1 out of 21. And vice versa now. From the English, I want to pick the green one, LS. So how many LS I have? 1 out of 5 over 1 out of 12. And from the French, I will pick what? GS, 1 out of 13 over 1 out of 21. So you have this answer here. I want both students from GS class, both from GS. So it GS English and GS French. So I say it is GS knowing English because I want to pick one from English, and GS knowing French. So in English, so I have how many GS? I have 7. So 1 out of 7 over 1 out of 12. And here in French, I want GS. I have 13. 1 out of 13 over 1 out of 21. I want both from LS. Both from LS. One I want to pick from English, one from French. So if one from English, I have 1 out of 5 over 1 out of 12, knowing from English, and LS from French. So I have 8, 1 out of 8 over 1 out of 21. Deduce P of A plus P of B plus P of C. 100% it's 1. Why it's 1? So because if you want to pick one from English, one from French, either you pick both to be GS, or you pick both to be LS, or you pick one, for example, from GS and one from LS. So this condition will give you all possibilities you may get in this experiment. So that's why it must be 1. Part B. In part B, suppose we need to pick a student. Here to pick one student, we return back to one universe. Find the probability of picking. He is in LS from France section. I said a condition. He is in LS, but I want to pick it مش at the same time. لو from LS and from French section, it will be intersection. But he said I want LS knowing from French section. So here the universe is France section. So how many we have in French section? So this is the universe. I want LS. So how many LS I have? 1 out of 8 over total 1 out of 21. So it will be 8 over 21. Suppose I said I want from LS and French, and at the same time French. So the total universe is everything 33 in that case. So LS and French. So how many I have? I have 8. So I say 1 out of 8 over total 1 out of 33. But I know I want from French section, so I go directly to French section. In that case, the French section will be the subuniverse. Find the probability that he is from French section, knowing he is LS. French, knowing he is LS. In that case, the subuniverse is LS. This is the subuniverse. I want the French, so how many French I have here? 8. So 1 out of 8 over total of the LS, because knowing from LS is 1 out of 13. Part C, from the set English, what is the probability? So, and I know also this is different types of writing knowing. From the set English, what the probability of picking a student from GS. So the universe now is the English. So I wanted GS, so how many I have? 1 out of 7 over total English, 1 out of 12. And the last one from LS student, come in, from LS, so knowing LS, find the probability of picking English. So now LS is the universe again. I want English, so I have 5. So 1 out of 5 over 1 out of 13. Suppose I said, what is the probability of picking a student who knows English and from LS? Who knows English and from LS? So it will be E intersecting LS. So here I don't have knowing. E and LS I have 5. So it will be 1 out of 5 because I don't have conditional probability over total, which is 1 out of 33. So I hope that you are understanding the total, the conditional probability. Another problem, the 40 students in a basketball club are distributed as shown. You have first secondary, second secondary, third secondary, boys and girls. So directly it will help you to put the total here. So we have 14 students in secondary 1. I have 11 in secondary 2. I have 15. And that makes a total of 40 students. How many girls I have as a total? I have 17. Here I have 23. This is the total of boys and girls. Okay. A group of 3 students is chosen simultaneously and randomly from this club. Consider the following event. The three chosen students are all in the 3rd secondary year. B, the 3 chosen students are all girls, each from a different year. The 3 chosen students are all in the same secondary year. Verify that probability of A. What's probability of A? Here I don't have conditional. I want to pick 3 students. I didn't say I want to pick a student, a boy and girl, one from here, one from here. What is the probability of picking if one from secondary 1 and the other one from secondary 2? So here it will be conditional. So I will talk about it anyway. What is the probability of P of A? The 3 chosen students are all in the 3rd secondary year. So I go, how many we have in secondary year? I have 15. So 3 out of 15 over total 3 out of 40. You can see it here. Calculate P of B. The 3 chosen students are all girls, each from a different year. Yani one from here, one from here, one from here. So 1 out of 6 combination times 1 out of 4 times 1 out of 7 over total is 3 out of 40. You can see it here. And P of C, the 3 chosen students are all in the same secondary year. So either you pick 3 out of 14 or the 3 are from secondary 2, 3 out of 11, or 3 plus 3 out of 15 over total 3 out of 40. So this is what combination where we have we don't have conditional probability. Part B, the chosen group is formed of 3 boys. What is the chosen group is formed of 3 boys. So we know that we have here 3 boys. So we know that we're picking the boys. So the condition here, boys. What is the probability that they are all from the same secondary year? Same secondary year. As in the same. So the universe here is not is boys because I know they are boys. So I say it will be 3 out of 8, or it will be 3 out of 7, or it will be 3 out of 8. Here, over total from the boys 3 out of 23, because I said I want all from boys. So here it's a sub-universe. In this part, we choose randomly and successively 3 students from this club. What is the probability that the first is in the first year, the second is in the second year, and the third in the third year? So we don't have condition here, so it's an arrangement. So I want it will be 1 out of arrangement 1 out of 14 times arrangement 1 out of 11 times arrangement 1 out of 15 over total arrangement 3 out of 40. What is the probability that at least one of them is in the first year? So minimum one of the first year, it will be 1 out of 40, 1 out of 14, and 2 not in the first year. So what remains? It will be 26, either secondary 2 or secondary 3, or it will be, so it's as you all know here, it's the same as we did before. But suppose I said I want to pick 2 students, one to be a boy and one a girl. Find the probability of picking one from first secondary and one from second secondary. But I want to pick one from boys and one from girl. What is the probability of picking one from first secondary and one from second secondary? You can say I will pick one from first, knowing a boy. So the other one will be second secondary, as we did the problem before, knowing a girl. Or I pick second secondary knowing a boy and first secondary knowing a girl. So here I have condition. Why I have condition? Because I want to pick one from boys and one from girls. So I have sub-universe. So the probability of picking from first secondary knowing a boy, so I have 8 out of, how many students I have here? 23. So it will be 1 out of 8 over 1 out of 23, which is 8 over 23. And then I want to pick, knowing from the girls, this is the girls, second secondary, so I have 4. So times 1 out of 4. And how many girls I have? 1 out of 17. Or second secondary, so I have 7. 1 out of 7 over 1 out of 23, because the number of boys is sub-universe. And I want first secondary knowing a girl, so 6 I have, times 1 out of 6 over 1 out of 17. I hope that you're understanding the conditional probability. Another kind of conditional probability, to understand it, in the previous one was tables. An urn contains 3 red marbles and 2 black marbles. So we have urn A. In urn A, we have 3 red and 2 black. Urn B contains 2 red and 3 black marbles. We pick a marble from urn A, we notice its color. So I'm going to pick one from A. I will see its color. Then we add it to urn B. So if you pick from A red, you take this red and you put it in B. If it's a black, you take this black from A and you put it in B. Okay? Find the probability of picking a red from A. To pick a red from A, so this is, I don't have, I have a conditional probability that I know I'm going to pick from where? From A. So I say probability of red knowing A, so what the probability of picking a red here is 1 out of 3 over 1 out of 5, so 3 over 5. Find the probability of picking a red from urn B. Now I want to pick from urn B, but I have something I need to do before, because I need to pick before from A. Knowing that we pick a red from A. So if you pick a red from A, so you're going to take this red and you're going to put it where? In B. So what happens in that case? In that case, in B, I have, because I have picked a red from A, I'm going to put it in B. So I have 3 red and 3 black. So I know that I have picked from a red. From A. Let me put R of A. So deduce the probability of picking a red. Find the probability of picking a red from urn B, knowing that we picked a red from A. So I want to find the probability of picking another red from B. Because I have picked a red from A, so now the total of red is a 3 and the black is a 3. So what we're going to get, you need to pick a red. So 1 out of 3, because I have a 3 now, okay, over 1 out of 6. So it will be half. Then deduce the probability of picking a red from A and a red from B. And I want to have the intersection of both. So the intersection, because I have this property, red of B knowing red from A, so I do cross multiply. So the intersection will be half R of B knowing R of A times P of red from A. To pick a red from A, we did it. It's 3 over 5, so it will be half times 3 over 5, which is 3 over 10. In part C, find the probability of picking a red from urn B, knowing that we picked a black. So if you pick a black from urn A, so instead of having 2 red and 3 black, so we're going to get 2 red, and we're going to add 1 black, so 4 black. So the probability of picking a red from urn B, knowing that we have picked a black from urn A, we have added 1, so it will be 1 out of 2 over 1 out of 6. So the answer will be 1 over 3. Then find the probability of picking a black from A and a red from a black from A and a red. Sorry, a black from A and a red from B. So here I will take this one. So I want P of red from B and black from A. So I do cross multiply. So I have this one, which is 1 over 3 here. And probability of picking a black from A. Black from A is what? Is 2 over 5, because I have 1 out of 2 over 1 out of 5. So it's 2 over 5. So I will get the answer. An urn contains 12 balls enumerated from 1 till 12. We draw from this urn. Let A, the drawn ball is even, B, the drawn ball is a multiple of 3. So what will be A? Even, the set of even, 2 till 12. Here, B, multiple of 3, 3, 6, 9, 12. Find the probability of A knowing B. Knowing B what? I know and the drawn ball is a multiple of 3. So knowing B, so B is the universe. So from this universe, which is B, I want to know how many 1 is even. So how many 1 is even? You have the 6 and 12. So it will be 1 out of 2 over 1 out of 4. So 1 out of 2 combination, 1 out of 2 over 1 out of 4. Why? Because here the sub-universe is B. So it will be 2 over 4, which is half. Find the probability of B knowing A. Knowing A, so the universe here is A. So I want B multiple of 3. So this is multiple of 3. This is multiple of 3. So I have 1 out of 2 here over total, which is 1 out of, let me count it, 1, 2, 3, 4, 5, 6, 1 out of 6, which is 2 over 6, which is 1 over 3. So knowing is, it means the sub-universe. Suppose there are 3 urns, each containing 4 balls. U1, you have 4 blue. U2, you have 2 blue, 2 yellow. U3, you have 4 yellow. Suppose an urn is selected at random and 1 ball is drawn and found to be yellow. We know it's yellow and found to be, so the universe are the yellow. So here the yellow and here the yellow. What is the probability? It's from urn 2. So I pick from knowing yellow, so I go only to yellow because I know it's yellow. What the probability of urn 2? So how many yellow I have in urn 2 here? I have only 2, so it will be 1 out of 2 over total number of yellow, because I have yellow. So I have 6, so it will be 2 over 6. And knowing from yellow from urn 3. So how many 1 I have? 1 out of 4 over total of yellow, because the universe is yellow. 1 out of 6, which is 4 over 6, which is 2 over 3. Another example. An urn contains 4 green balls. So let me do it. You have 4 green and 5 blue. We draw randomly 2 balls. What the probability for the second ball to be blue? Second one, I want to draw 2 successively. What the probability for the second ball to be blue, knowing that the first one is blue? I want to draw balls and I want to draw the first one. I will keep it to with myself. So what is the probability of picking another one blue? Because I have picked a blue one, so I don't have any more 5 blue. So what remains? Remains 4 green and 4 blue. So what the probability of picking now a blue? It will be 1 out of 4 over 1 out of 8. So it will be 4 over 8, which is half. Okay. Knowing that the first one is a green, what the probability of the second ball to be blue? Knowing that the first one is a green. Because I know the first one is a green, now what do I have? I will get 3 green and 5 blue, because already I have picked 1 green. So what the probability of picking a blue now? So 1 out of 5 over 1 out of 8. So it will be 5 over 8. So part B, what the probability for the first ball is blue, knowing that the second is green. So I know in the second row I want to pick a green. So let us take out 1 green. So what remains? 3 green, 5 blue. I want to pick a blue one. So it will be 1 out of 5 over 1 out of 8. So similarly 5 over 8. I know that the second one will be blue. So what will be? 4 green and 4 blue. What will be the probability in the first to be a blue? So 1 out of 4 over 1 out of 8 is 4 over 8. Okay. Check if the following events are dependent or independent. So for dependent and independent events, guys, either you have P of A intersection B is PA times PB, or P of A knowing B, if you have conditional probability, will be equal P of A. If you have these two, one of them, so it's correct. It will be independent. Here you have PA, PB, and P of A union B. You know, you need to find to be independent P of A intersecting B. P of A union B is 0.44. P of A is 0.2, P of B is 0.3, so P of A intersecting B, if you do the calculation, 0.06. So we do PA times PB. Here we don't have conditional probability to use the second one. I use the first one. PA times PB, if you do 0.2 times 0.3, it is the same as 0.06, so the two events are independent. We did one in the first part similar to this. Now they gave us conditional probability, P of A knowing B. We know it's P of A intersecting B over P of B. They gave us P of B, so I have here 0.5, here 0.1. So what will be P of A intersecting B? 0.05. Okay. Now, to know if it's independent, either I use this one or this one. If I want to use this one, I don't have P of A, because to be independent, P of A knowing B must be P of A. P of A already I didn't find it, so I find P of A. How do I find it? I use the union. I have still one given. P of A union B is given. P of A I want to find. P of B is 0.5. P of A intersecting B is 0.05. So I'm going to get P of A 0.1. You realize that P of A knowing B is P of A, as you can see. So it's independent. So I hope that you got the conditional probability. I know it's a long video because I'm explaining the problem application. So see you in the assignment.